problem up here. This one's going to be mostly for you to try, but I want to do the first bit together just because I want to show you an option that you have. So we'll notice this is a linear trig function because the biggest power of our trig function that we have is just the first power. So I want to isolate it. I want to get it to trig function equals number. Okay. So I'm going to subtract over that 5. So 4 secant of x equals negative 5. Divide both sides by 4, so secant of x is negative 5/4. Now, that is a legitimate value for secant, because remember, secant takes on values 1 and bigger and negative 1 and smaller. If I wanted to solve it from here, I certainly could. Okay. Now, that's not going to have a nice reference angle, so I'm going to be using inverse trig to describe it. Okay. But what I would prefer to do is to rewrite this as cosine of x is negative 4/5. Because remember, cosine and secant are reciprocals of each other. So as long as cosine isn't 0, so that I can actually take reciprocals, I can do this. I prefer this because I'm more familiar with cosine and I'm more comfortable working with cosine. So I'm going to go ahead and solve this in terms of cosine. It's an equivalent version of the equation. Certainly not wrong to solve it in terms of secant, and if you prefer to do that, that's totally fine. But I'm going to go ahead and solve this in terms of cosine. So take a moment, pause the video, work this one out, and then we'll check the answers together. So I've chosen to work with the version in terms of cosine. And so thinking in terms of quadrants, I want to look for where cosine is negative. Now that's going to be in quadrants 2 and 3. So I'm going to have two pictures that look like so. Now, if I wanted to, I could just say that this x is arc cosine of negative 4/5, because arc cosine does spit out obtuse angles. Okay. However, usually what I prefer to do is just say, you know what, I can describe both of these in terms of the same reference angle. And that's going to be simpler because that way I'm just always describing my solutions in terms of the same reference angle, which is an acute angle. Okay. So I would say that that cosine of alpha, rather, is the absolute value of negative 4/5. It's just 4/5. And since alpha is an acute angle, it's in the range of every inverse trig function. Alpha is arc cosine of 4/5. Okay. So as long as I choose to work with the reference angle, I know any inverse trig function is good. So here I would just say x is pi minus alpha, so that would be pi minus arc cosine of 4/5. And here I would just say that x is pi plus alpha, so that would be pi plus arc cosine of 4/5. Okay. So this is how I would describe my two answers to part A. That's not the only way I could describe them. As I said, I could have said that this was arc cosine of negative 4/5. This obtuse angle here would actually be the same as this obtuse angle here. So I could have described this solution as 2 pi minus arc cosine of negative 4/5. But I kind of like to have just one procedure that I can apply to all of these functions. Okay. But the fact that there are different options, I could have also solved this problem in terms of secant, and then instead of having arc cosine of 4/5, I'd have arc secant of 5/4 in these two places. So the fact that there are multiple ways of expressing the same answer means that as you're doing the homework and checking your answers in the back of the book, you might have done a problem right, but not have an exact match in the back of the book. Okay. Sometimes you can look at an answer and you can say, ah, yeah, I can see why that's equivalent to what I have. I feel great about that. If you're not sure, what can be useful to do is just to take a calculator, plug in your version of the answer, plug in the book's version of the answer, make sure you're in radian mode if you're giving things in radians. If the decimal approximations that your calculator gives you are the same, then chances are that those answers are the same. If that fails and you're just not entirely sure, you're always welcome to send me an email and say, I got this answer, the book got this answer, I think they're the same, are they? And I'm happy to help you out with that. Okay, excellent. So those are our solutions between 0 and 2 pi. All solutions then would be pi minus arc cosine of 4/5 plus 2 pi n, and pi plus arc cosine of 4/5 plus 2 pi n, where in both cases n is an integer. And as with this problem, if you wanted to consolidate your multiples of pi and combine those to say that's 2n plus 1 copies of pi, or an odd multiple of pi, that's totally fine. It's up to you. I would accept multiple versions of the answer to this problem.